Hello, welcome to this video. Today we are going to be doing a little bit of 6.2 and really focusing on volumes of solids of revolution. As motivation for our lesson today, I just want to review this quick little animation. So y equals root x is drawn, and now we'll draw in y equals 1/10 x, and we're going to bound that region with x equals 4. So the red is our region that we are revolving around the x-axis. See there, our shape. And if we take this little slice that we're talking about, it looks like this washer. And so that's the washer method we are talking about. And so in essence, what we're doing is this radius outer and then subtracting the radius inner out to hollow our final shape. So let's go ahead and break that down. So based on the animation that we just saw, what is the area of that hollowed out shape? Here are all the equations that we have. We can see that our radius outer is this longer one, and this curve right here is obviously the y equals root x, and then this line right here is obviously the y equals 1/10 x, and then the x equals 4 is just our bound, so it's not really anything involving our radius outer or our radius inner. So I'll just write it right here. This is our radius outer, and this right here is our radius inner. And so how do we find the area of this hollowed out shape? Well, really, that's just a shape that looks like this. And how do I find the area of this kind of a donut shape? We're calling them washers. That's our radius outer. I'm just going to abbreviate it R out. This is our radius inner. I'll just abbreviate it R in. The only way to find the area of that shape, area, is the outer minus the inner. That's the only way that we can get the area of that hollowed out 2D shape. So pi radius outer squared minus pi radius inner squared. Notice this is not the same as pi radius outer minus radius inner, the whole thing squared. That's not what we're going for. We really need the big circle minus a small circle. So this is what we're going for. And if we use the equations that we have, let me just erase this part, then we have pi root x squared minus pi 1/10 x squared. And I'm just going to leave it like that for this problem. So now my question is, can you set up an integral that represents the volume of this region revolved around the x-axis? So we're going to be revolving around the x-axis. We had just found that the area is pi radius outer squared minus pi radius inner squared. In this example, it was pi root x squared minus pi 1/10 x squared. Our volume, remember, is just adding up all those slices. So you're adding up all those slices, and remember that we're going perpendicular to the axis we're rotating about. We're going from 0 to 4 because that was our bound. So we're going from 0 to 4, pi radius outer squared minus pi radius inner squared. You do not need to write this every time, what you're actually doing, and actually you can factor out the pi here, right? The pi is in common, so you really could factor it out. So for this particular problem, it's pi integral from 0 to 4 of that root x squared minus the 1/10 x squared dx. Do not get that confused with finding the area of just this region, which is what we did in 6.1. So if I wanted just the area of this region, the area is you're adding up all the slices of those lengths, and that length was the top curve minus the bottom curve. So the area of this would be, you're adding them all up from 0 to 4, root x minus 1/10 x dx. That is the answer to the area if I'm not doing any revolving. When I label area here, that's the area of one of my slices when I'm revolving. Okay, now I want to do this worksheet together, and I think that by doing all the questions on this worksheet, we're going to break it down in a way that this is all going to come together for you. So just be patient and wait until we do all these different types together, and you'll start seeing a pattern, and hopefully you'll be like, oh, I like this section. All right, so consider the region in the first quadrant bounded by y equals x squared and y equals 8 root x. So hopefully you know which is which. This bottom curve here looks like y equals x squared. I'm going to change my color to blue for 8 root x because that looks like our square root graph, right? Part A just asks us for the area between the two. So the area, remember, is you're adding up all these slices. So we're going from 0 to wherever they intersect. This graph I squished down so much I can't see where they intersect, so I'm just going to figure it out. It's a good exercise to do anyway. So where do these two intersect? I'm going to square both sides first. So I have x to the fourth equals 64x. X to the fourth minus 64x equals 0. Take out an x. X equals 0, obviously there. And then the cube root of 64 is just 4. So that's going to be my other bound. So I'll be going from 0 to 4. This is my area. And I'm adding up all these slices. And the length of this slice is the top curve, which is blue, minus the bottom curve, which is red. Okay, we're just setting up in these questions, and so that's all I have to do. In this next one, we want the volume obtained by rotating around the x-axis. So just go ahead and draw in your radius outer and your radius inner. So remember, you're going from the curve to the axis you're rotating about. From the curve to the axis you're rotating about. The longer one, this one right here, is going to be the outer, radius outer. So the longer one is radius outer. The shorter one is going to be your radius inner. You'll see that these might flip-flop depending on how the question is asked. So you just want to draw in the lines and see which one's longer. This line right here, the length of it is from the curve to 0. So radius outer is going to be 8 root x minus 0, which is just 8 root x. And then the radius inner is going to be this curve minus 0, x squared minus 0, which is just x squared. And so the volume, I'm going to factor out the pi integral. Again, we're going from 0 to 4 because we're doing dx slices. Radius outer squared minus radius inner squared. This next problem wants us to rotate around y equals -1. So y equals -1 is going to be down here. So again, go from the curve to the axis we're rotating about, from the curve to the axis, or sorry, the line we're rotating about in this case. This one's still going to be longer, so the radius outer now is going to be from the curve minus a -1. Because remember, you go top minus bottom. So this is going to be 8 root x minus a -1, which is 8 root x plus 1. Our radius inner is going to be from here minus a -1. So our radius inner will be x squared minus a -1, x squared plus 1. So our volume in this case, I'm going to factor out the pi again. We're still going from 0 to 4. We're still adding up all the x stuff. Radius outer squared minus radius inner squared. All right, our next set of questions, still dealing with the same two curves. So that was y equals x squared and y equals 8 root x. I'm just going to highlight them again. Now in this first question D, we're rotating around y equals 20. So y equals 20 is going to be all the way up here somewhere. And so when I do this, look at what happens. If I go from the curve to the line we're rotating about, from the curve to the line we're rotating about, do you see how now this one is my longer one? So now that's going to be my radius outer. They kind of flip-flop because the longer one is now the red line. And this is going to be my radius inner. Also, when I want the length of this, I have to go top minus bottom. And now the top is my y equals 20 curve. So I'm going to be doing 20 minus 8 root x. If you draw what I'm drawing, everything becomes easy. But if you don't do that and you just try and remember, do I do top minus bottom? Do I do bottom minus top? Which one's radius outer? Which one's radius inner? It becomes confusing. Just draw and it's so easy. You're like, oh, top 20 minus, what's this curve? X squared. 20 minus x squared. Then to get our volume, we just do the same thing. Take the pi out. We're still doing dx slices, so we're still adding up from 0 to 4. Now the radius outer is going to be this 20 minus x squared thing, squared, radius outer squared, minus radius inner, squared dx. All right, now in the next one, we are rotating around the y-axis. So now we're going this way. So perpendicular is going to be dy slices. So that's going to change things up. what are my new bounds going to be? Let's go back for a second. We found the intersect was x equals 0 and x equals 4, but what is y? You can choose either of these two curves because obviously they intersect. The y is going to be the same no matter which one you plug it into. If x equals 0, then I'm just going to use x squared. Then y equals 0 squared is 0. If x equals 4, then y equals 4 squared is 16. So now my new bounds are going to be 0 to 16 there. I'm going to take the pi out. I'm just going to write that because that's what we're doing now, right? We're adding up all the slices. Boop, 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 boop. Y slices because we want to go perpendicular there. So we're going from 0 to 16 in this case. Before we were going 0 to 4, now we're going 0 to 16. Now, draw in, same thing, from the curve to the axis we're rotating it about. The reason I need this direction is because we want to go perpendicular to the axis we're rotating about. So that's why they're looking like this. And so our radius outer is the longer one, but since I have dy slices, I need y stuff. I can't have, this isn't x squared minus 0. I need it in terms of y. So y equals x squared is the same thing as x equals root y. Technically it's plus or minus root y, but I only have this side of the curve, right? I don't have this side of it, so I don't have the negative. I just have the positive. And then y equals 8 root x. Well, let's go ahead and divide both sides by 8. Y over 8 equals root x. And then let's square both sides. So we get x equals y over 8 squared. You could have y squared over 64 or just leave it like that. I don't care. So now the red curve is just our radius outer, and that's going to be our root y minus 0 in this case, which is just root y. And then our radius inner is going to be this y over 8 squared minus 0, which is just y over 8 squared. We already have our pi. We have our integral from 0 to 16. Our radius outer squared minus our radius inner squared. So we're going to have to square because this was squared already. So that's our answer there. Now in the next one, we want to rotate around x equals. So x equals -1 is there. So here's our longer line. Our radius outer is going to be this root y. And now we're going to do minus a -1, you see, because we're going over to here. So minus -1, which is root y plus 1. And our radius inner is going to be from here minus a -1 again. So we're going to have y over 8 squared minus a -1. Y over 8 squared plus 1. Our volume, pi, again, we're going from 0 to 16 because we're doing dy slices. Radius outer squared minus the radius inner squared dy. Lastly, we want to rotate about x equals 10. And so remember, this was 4 right here. So x equals 10 is going to be somewhere over here. So we're rotating there. Now, again, we go from the curve to the line we're rotating about. From the curve to the line we're rotating about. You see how we're flip-flopping. Now this one's longer. This is going to be our radius outer. And what is it? We have to go from right to left. So we start here at the 10 minus, so 10 minus y over 8 squared. And then our red is going to be 10 minus root y. So now our volume, take that pi out, 0 to 16, radius outer squared minus radius inner squared dy. Okay, so now hopefully you got those down. We're going to do a couple of volumes by cross-section. So these ones are not rotating. This one just says, for the solid, the cross-section perpendicular to the x-axis are squares. Let me do my colors again. That was y equals x squared. And then these, that was y equals 8 root x. So in the case of my square, this is my base. And then the squares are going to be popping out at me, okay? I'm not good at drawing 3D, but the squares are going to be popping out at me. And a square, all the sides are the same length. And this is one of the sides. And what is that length? That length is top curve minus bottom curve. In other words, the blue minus the red, 8 root x minus x squared. So it's a square. This is also going to be 8 root x minus x squared. Your first step is going to be to find the area. So the area of the square is simply 8 root x minus x squared squared. That's it. And the volume is just adding them all up from 0 to 4 in this case. So the volume is adding up all the areas from 0 to 4. That's all I do. That's it. Absolutely it. In this next one, it says for the solid, the cross-sections perpendicular to the x-axis are isosceles right triangles where the base is the hypotenuse of the triangle. So the hardest part of this one is to figure out what the area of the triangle is if you're given the hypotenuse. And this hypotenuse is going to correspond to this black part. So I'm going to have this isosceles triangle. I don't know what these two sides are, but I know that the black part is this length. And we found that that length is just top curve minus the bottom curve, 8 root x minus x squared. But what is the area of this? You know that the area of a triangle is 1/2 base times height, but I don't have the base or the height, but I do know that this is isosceles, so those are the same. So I'm going to just break it down here for a second. You know that this is a 45, 45, 90 triangle because it's an isosceles right triangle, right? So we know if this is 1, then this is root 2 over 2, and this is root 2 over 2. So basically, if this side length is 8 root x minus x squared, then what is this side length? I would just multiply it by root 2 over 2. But for the sake of this, let me just simplify this down, and let's just say that this is my x, then this is root 2 over 2x, and this is root 2 over 2x. So what is the area of this triangle? The area is going to be 1/2 base times height, and the base and the height in this one are the same, right? So I'm just going to square it. So I have 1/2, root 2 squared is 2, 2 squared is 4x squared. So I pretty much have 1/4 x squared, where this side length is my x, and isn't that what I'm given there? So that's great. I can just go ahead and say 1/4 hypotenuse squared is the area of my isosceles right triangle. So the area of my triangle is going to be 1/4 hypotenuse squared. It's kind of my like little proof of why I'm doing that. And then to find the volume, literally all I'm doing is I'm adding them all up from 0 to 4. dx, and you could take that 1/4 out to make it a little bit easier if you did need to solve it. I'm not asking you to solve any of these. Final one here is they're saying that now we have semicircles where the base is the diameter of the circle. Okay, so that's really important. The base is the diameter. So it's going to look like that, and then you have the semicircle. So it's just a semicircle, but this base here is the diameter. And remember, the area of a semicircle is 1/2 pi r squared. That is our 8 root x minus x squared, but that's the diameter. So our radius is going to be a half of that. Our radius is half of the diameter. 8 root x minus x squared all over 2. So our area is 1/2 pi. So I'm just going to do pi over 2 r squared. So our volume is going to be, I'll take the pi over 2 out, integral from 0 to 4, 8 root x minus x squared all over 2 squared. I honestly probably would have taken that 2 squared out and made it a 4, so I probably would have done pi over 8 integral from 0 to 4 of 8 root x minus x squared, the quantity squared dx. Again, in case I needed to actually integrate, again, all I did was take the 2 squared out, and 2 times 4 is 8. All right, continuing on. We are going to be doing a bunch of these problems in a row together with the same directions, just different curves. So please maybe do this one with me, and then for the next one, pause the video, try it, and then watch the video to make sure you got it. Hopefully you'll get a pattern and these will start feeling easy by the end of this video. So this first one, we have y equals x to the 1/3 and y equals 5x squared. So hopefully it's obvious that the green curve is the x squared one and the blue curve is the x to the 1/3 graph. If you can't tell which one's which, just think about the squared one, you know which one that one is. And I actually give you the bound right there, and we know that's 0, 0. So the bounds of integration, we are rotating in this one around the x-axis, and so that means we're doing dx slices. So our bounds will just be 0 to 0.381. And even though that's part A, I know that my goal in part D is to set up the volume equation, so I'm just going to put that answer right down here. Draw the radius outer and radius inner, so I'm just going to go from the curve to where I'm rotating about, from the curve to where I'm rotating about. The longer line is my radius outer, so our radius outer is going to be top minus bottom, x to the 1/3 minus 0. The radius inner is going to be top minus the bottom. That's the shorter one. Radius inner, 5x squared minus 0. So now to get my integral, I'm going to just factor the pi out. I'm adding up all the slices from 0 to 0.381. Radius outer squared minus radius inner squared dx. Now, in this one, they want us to actually solve using our calculator and using the store function, because this is really important for you to be able to do this for the AP. We need exact answers, so you need to be able to store. So let me show you how to do that. So I'm going to put into y1, x to the 1/3, and then in y2, I'm going to be putting in my 5x squared, and then I'm going to graph. And now I need that intersection point, but it's super hard to see. So what I'm going to do is I'm going to just do a zoom. Zoom decimal will get me zoomed in a little bit more. I really like that window. And so now what I'm going to do is I need to find that exact intersection point. So I will get that by going to second calc. And then I will be going to intersect, which is number 5. Go over on the first curve to the point, press enter. On the second curve, get as close to the point, and then enter the third time. And so this is the intersection point that you need to be using exactly. So the 0.381 is probably not going to cut it for 3 decimal place accuracy. So to store that value, what you'll notice if you go to the home screen at this moment in time and you press X, that's the X value. Now the problem is that the X value is going to be changing. Every calculation that I do, it'll store a new value in X, but I want to save it in a safe space somewhere that it's not going to change. X is going to change over time, Y is going to change over time. So you don't want to use those 2 letters for anything that you want to store, because they're going to be changing. But all the other letters of the alphabet you can use. So I'm going to take this X and I'm going to store it. So you see right here, this key right here is store. I'm going to store it in any other letter in the alphabet. So you use the alpha key and I'm going to just store it in A. So store that in A. And now what were we trying to do? We were doing pi times the integral from 0 to that A of y1 squared minus y2 squared dx. So I'm just going to write that. So what we did was we took this X value and we stored it in A. And then our volume is going to be pi integral from 0 to A of y1 squared minus y2 squared dx, because I had stored this in y1 and this in y2. So let's do that in our calculator. We're going to use math 9, which is fn int. We're going to go from 0 to A, alpha A, and then here I'm going to do vars y1 squared minus vars y2 squared dx. Enter. And there's my answer. Now, while we're on this slide and while we're using our calculator, I just want to show you one other thing. What if, and we're probably going to come up to it later, so I may as well do it right now. What if I was asking you a problem where I'm rotating around the other axis and I really needed y bounds? Then let me find this intersection points one more time. So I already have my X stored in A. Why don't I store my Y in B, just in case I need to use it in another problem, which I might have to. Then I'll have both bounds saved. So what I'm going to do for that is, this is my X button, but you know what? Alpha Y is going to actually give me whatever's in my Y. You see that? That's that. My intersect was that same thing, the 0.724777966. I know you're probably thinking right now, I could write all those numbers down. I got it. On the AP, sometimes they give you problems where if you don't store the values, you're not going to get the right answer at the end. So this is one of the things that's required for me to teach you on the AP exam. So just bear with me on this one and trust me. All right, let's take this Y value and let's store it in our B. So now, even if I do some more computations, I'm not going to lose that value. All right, now we got it saved for later. Let's go back to our Pear Deck. So you go ahead and tell me how comfortable you are feeling about storing the X values and the Y values on your calculator. Same problem again, but this time we're rotating around y equals 30. So y equals 30, it's not here. It's going to be way up. This is only 1, but I'm just going to draw it because it's above, okay? Good enough. Now, go from the curve to the line we're rotating about. That's like that. From the curve to the line we're rotating about. That's like that. Our bounds of integration, we still have X slices here, right? So our X bounds are going to be the same from 0 to 0.381 in this case. Just going to take the pi out because I know I'm revolving and I'm going to be using that. That's part A. Radius outer, that's the longer line. So in this one, it's the green one. And we have to go top minus bottom. So the radius outer, top is 30 minus, and the green one was the 5x squared. Our radius inner, top minus the curve. So again, 30 minus that x to the 1/3. Now when we set it up, we're doing pi radius outer squared minus radius inner squared. Because again, that was the pi radius outer squared, pi r squared, minus another pi r squared, but we had factored out the pi. Okay? Now we're revolving around y equals -2. Y equals -2 is going to be somewhere over here. So now we're doing dy slices. We're going this way, right? So now our bounds of integration are going to be from here up to the y, which is that 0.7248. Our radius outer is going to be curve to the line we're rotating about. Our radius inner, curve to the line we're rotating it about. The blue one is the shorter one, so it's our radius inner. Now, what is this line? Because we're doing y, we switch things so we get everything in terms of y instead of in terms of x's. Y equals x to the 1/3 is going to be cube both sides. X equals y cubed. Y equals 5x squared is going to become divide both sides by 5. X squared equals y over 5. And then take the square root. X equals, and I'm just having the positive root because it's just the top one, y over 5. So our radius outer is the green one. Right minus left is going to be that y cubed minus a -2, y cubed plus 2. And then our blue one is going to be our radius inner, root y over 5 minus a -2, root y over 5 plus 2. So our volume, pi radius outer squared minus radius inner squared, dy. And you know what? I just did all that work and I realized this is y equals -2. And I just did x equals -2. So I'm changing the instructions to x equals -2. Sorry, I'll do y equals -2 again in another problem. Okay, that's going to make this next part really easy when we want to rotate now about the y-axis, because we've already done all the hard work in the last one. We have already said that our bounds are now going to be 0 to 0.7248. And so we had said that this y equals x to the 1/3, which was our blue curve, is equal to x equals y cubed. And then this y equals 5x squared, which is our green curve, is equal to x equals root y over 5. So we could rewrite it like that. And then our longer line is going to be this green line. So that's going to be our radius outer. And so that's going to be root y over 5 minus 0, which is just root y over 5. And our radius inner is going to be this line right here, which is the shorter one. Radius inner is going to be that y cubed minus 0, which is just y cubed. And so our volume is going to be pi times the integral from 0 to that y bound, 0.7248. Radius outer, root y over 5 squared minus radius inner squared dy. Okay, so now they want us to do this one with our calculator. So we already set everything up. Remember last time we put it in B, so that y equals 0.7248. We had stored it in our calculator in our alpha B. And so what we're going to be doing is volume equals pi, and then we're going to use fnint for our integral 0 to alpha b. And in this case, we don't have things stored in y1 and y2, so I'm just going to type it all out. Instead of root y over 5, we want everything in x's for our calculator, so I'm just going to be writing root x over 5 squared minus x cubed squared dx. Because we're just using our calculator as a computational tool right now, I had already set everything up properly, so it doesn't really matter what our letter of our variable is. It's kind of like a lot of times when we're doing physics applications, instead of t's in our calculator, we put all x's in. So we had already set all of this up, so that's really important that you had set it up properly. Obviously, the curve that's being drawn is not root x over 5, but we already had our bounds based on this being root y over 5. So we're just using our calculator to compute this as simply a computational tool. So on our calculator, we would do pi times math 9, 0 to alpha b, and now I'm doing that root x over 5, all under the root, squared, minus x cubed squared dx. And that should be my answer, 0.1179. All right, in this question, they're asking us now revolve it around x equals 5. So let me get my x equals right this time. X equals 5 is going to be here. And so now this is going to be my radius outer, and this is going to be my radius inner because it's shorter. So my volume is going to be pi integral. I'm doing dy slices still here, right? Because my slices are this way. So I'm adding them all up from 0 to 0.7248. And then my blue is my radius outer, and I have to go right minus left. So I'm starting at this 5 minus the blue curve, which was my y cubed. And then my radius inner is going to be 5 minus my green curve, which was root y over 5. So my volume is pi integral radius outer squared minus radius inner squared dy. Now this one says revolve around x equals -2, which I had done previously. So why don't we change this instruction to y equals -2 so we get to practice what I meant to do the first time. So now our radius outer is going to be the longer one, the blue, and our radius inner is going to be the shorter one, the green. The bounds of integration for this one, take the pi out, are going to be, now we're doing dx slices, right? Because we're going this way. So we're going from here to here, 0 to 0.381. Our radius outer is going to be the longer one, the blue, top minus bottom. Now we're doing dx's, so we stick with the dx's, and this is our blue curve. So we have x to the 1/3 minus a -2, x to the 1/3 plus 2. Our radius inner is going to be this curve minus a -2. So 5x squared minus a -2, 5x squared plus 2. Our volume, pi integral radius outer squared minus radius inner squared. All right, guys, we're getting there. What is the area of an isosceles right triangle in terms of the hypotenuse h? So we went over this a little bit earlier, but I want to do it again because I know that people get tripped up on this. So if I give you the hypotenuse, then what is the area of this triangle? Remember, it's isosceles, so that's a 45, 45, 90 triangle. What you need to remember about your 45, 45, 90 triangle is if this is 1, then this is root 2 over 2, and this is root 2 over 2. So that means if this is x, then this is root 2 over 2x, and this is root 2 over 2x. Let me call them h's because I called that h. So let's revise this. That's h, and that's h, and that's h. So what is the area? The area of this guy, so I use this to get to there. The area of this guy is going to be 1/2 base root 2 over 2h times height, which is also root 2 over 2h, which is 1/2 root 2 over 2 times root 2 over 2 is 2. 2 times 2 is 4. H times h is h squared. That's 1/4 h squared, okay? So the area is 1/4 h squared of an isosceles right triangle in terms of the hypotenuse h. What is the area of an equilateral triangle in terms of the side length s? So if I have an equilateral triangle, that means all the sides are the same. Then what is the area of the triangle in terms of the side length s? Well, I kind of have to break it down like this. I have a triangle, right? But I know the area is base times height. And this was 60, 60, 60. If I break this in half, then I'm just going to take this half right here and magnify it, okay? That's S. Now this is 1/2 of S. This was 60, so it's going to stay 60, but I bisected this one, so now it's only 30. Oh, look, I have my 30, 60, 90 triangle. If this is S and this is 1/2 S, what do you know about your 30, 60, 90? If this is 1, then this is √3/2, and this is 1/2. So if this is S, it's going to be 1/2 S, and this is going to be √3/2 S. And so the area of this triangle is going to be 1/2 base times height. And so that's going to be 1/2. 1 times √3 is just √3. 2 times 2 is 4. S times S is S squared. √3/8 S squared. Now that was just half of this triangle. I should have just gone back over here and just drawn in my height at this point, probably. So you know your height now from this one is that √3/2 S. And so the area of this triangle is going to be 1/2. The base in this one is S. 1/2 base times height, which we had figured out. And so that's going to be 2 times 2 is 4, and we have the √3, so √3/4 S times S, S squared. That is the area of an equilateral triangle in terms of a side length S. Trying to make the algebra a little bit easier so we can concentrate on the calculus in this class, okay? So we're almost there. Now we're going to just do some where the base, we're going to apply what we just learned. The base is one of the sides of the square. So if the base here, that's our region, right, is one of the sides of the square, then that means that this length right here is top curve minus bottom curve, which was x to the 1/3 minus 5x squared. So our area, the base times the height, is the same, x to the 1/3 minus 5x squared. So the bounds of integration, these are going to be dx slices because it's perpendicular to the x-axis, 0 to 0.381. We drew the picture, and now we're going to set up the integral. So we're going to add up all of those little areas. X to the 1/3 minus 5x squared dx. We don't have any pi's because we're not revolving anything now. All we're doing is we're literally adding up all of these areas of the squares in this one. Now, graphing practice. Do you know what this is the shape of? Hopefully you know it's a shape of an ellipse. How do we draw this? We do not need anything fancy, okay? You know the general shape of a circle is x squared plus y squared equals r squared. Hopefully you know this is a general shape of an ellipse, and how I draw this is all I really care about is the x-intercept and the y-intercept. We know it's an ellipse and we can draw our shape. Our x-intercept, we make the y 0, 25x squared equals 100, divide by 25, x squared equals 4, x equals plus and minus 2. So go ahead and graph that as the x-intercepts. And then the y-intercepts for y squared equals 100, divide both sides by 4, y squared equals 25, y equals plus or minus 5. And then it's an ellipse, so that is good enough for me. So that's absolutely all you need to be able to do for this class. As a final thing that I'm going to be saying, we will have to figure out the length of this in this class for obvious reasons, hopefully after this lesson. And so how you think about that is you think about, you need a y equals equation, and this isn't y equals. So let's get a y equals equation. We have 4y squared equals 100 minus 25x squared. Divide everything by 4. Y squared equals 100 divided by 4 is 25 minus 25 fourths x squared. Y equals plus or minus √25 minus 25 fourths x squared. The plus or minus is because of this. The top half, which I will highlight in yellow here, is the positive. Y equals positive √25 minus 25 fourths x squared. And the bottom, I'm going to highlight in green, is the negative part. Y equals negative √25 minus 25 fourths x squared. And guys, if anybody is tempted to say that this equals 5 minus 5 halves x, no, please don't do that. We're not allowed to do that. Algebraic atrocity 101. You cannot split it up like that. Anyway, back to what we were saying. To find this blue length here, I would do top curve minus bottom curve. So root 25 minus 25 force x squared minus the negative 1 is simply going to be 2 root 25 minus 25 force x squared. And you'll see how we're going to use that in some applications coming up with ellipses that we're going to do that are very popular on the AP exam. But I just wanted to show you that we just have to be able to graph it very simply by finding the x and the y intercept. And then when you solve it for y, don't forget about the plus and minus, because we need to do top curve minus bottom curve. And that's why we're going to get, for this whole length, if we're looking for the whole length, it's 2 root whatever. Okay, so you are going to finish this by, in your own Pear Deck, tell me something that this Pear Deck session helped clarify, one thing you will go back to review after this Pear Deck session, and a major takeaway, note to self reminder from the Pear Deck session. And that's it for this lesson. Bye.